This is 4.4 factoring quadratic expressions. So today we're going to be finding common and binomial factors of quadratic expressions. We're going to factor special quadratic expressions, perfect square trinomials, and the difference of two squares. The assignment is on pages 221 to 222, numbers 15 through 57 odd, 61 to 77 odd. This will be due at 8 a.m. before our next class. The quiz is also posted on the whiteboard in blue dry erase marker. It's under the everyone is welcome sign. It will be November 6th, and we're just going to add one more section, 4.5. So factoring is a method we use to rewrite an expression as a product of factors. It's the inverse operation of distribution of multiplication. The greatest common factor, sometimes abbreviated GCF, is the common factor of each term. Make sure that it's all the terms and not just some of the terms. It has the greatest coefficient and the greatest exponent. So for instance, example, we have 4x cubed plus 20x squared minus 12x. Since 4 is divisible into 4 itself, 20 and negative 12, 4 is the constant that can go into all three. And there's an x cubed, an x squared, and an x to the first power here. Even though the 1 is not given, this is x to the first power. The GCF is 4x. Okay, that's the next blank. Sorry. Okay. Perfect square trinomial. Perfect square trinomial is a trinomial that is the square of the binomial. So if you take a two-term polynomial like 5x squared, 5x minus 3, and you square it, you would get what's called a perfect square trinomial because it's a square of this binomial. That you get three terms, that's where the trinomial comes into play. FOIL is a method used to remember how to use a distributive property twice. So in this example, you would write 5x minus 3 twice. Then you would take the first terms and multiply them. 5x times 5x is 25x squared. Take the outer factors or values, 5x times negative 3, get negative 15x. Inside is negative 3 times 5x, which is also negative 15x. And then the last would be negative 3 times negative 3, which is 9. Combining the like terms, we get 25x squared minus 30x plus 9. Here are your steps that are already written on your notes. We're going to find the factors of the constant, find the two factors whose sum is the coefficient b, and write the trinomial as the product of two binomials. And this is, sorry, move this over. This is only when a is either positive or negative 1. So when you're looking at ax squared plus bx plus c, this is only for when a is 1. So what we're going to do is we're going to find the factors of 40 that add up, and we're just going to look at all the factors. So 1 and 40, 2, 20, 3 is not divisible into 40, but 4 is. 4 goes into 40 10 times, 5 goes into 40 8 times, and vice versa. So we're not going to name the ones where it just reverses the order. If I were to add 1 plus 40, I would get 41. 2 plus 20 gives me 22. 4 plus 10 is 14. And 5 plus 8 is 13. So of these factors, the only ones that give me 14 are 10 and 4. So my factors are x plus 10 and x plus 4. So we just factored, it is not prime. For B, I'm going to take the factors of 30. Because 30 is positive, but B is negative this time, I need to make sure that my two factors are both negative. Negative 1 times negative 30 is positive 30. And negative 1 plus negative 30 is negative 31. Okay, so I'm going to write negative 2 and negative 15, negative 3 and 10, negative 5 and 6. Sorry, these are both negative. And then I'm going to add them. Negative 2 plus negative 15 is negative 17. Negative 3 plus negative 10 is negative 13. And negative 5 plus negative 6 is negative 11. So of these that add up to negative 11, only negative 5 and 6 work. And you can always check the work to see if I did it right by distributing with FOIL. For C, I'm taking the factors of 21. 3 times 7. Why did I start there? I'm not sure. Start with 1 and 21, 3 and 7. Okay, that's it. 1 plus 7, 1 plus 21, sorry, is 22. That's 22. 3 plus 7 is equal to 10. Since there are no factors that add up to 4, I say prime. Okay, stop the video and try to do, oh, sorry. We should factor out the negative first. You get x squared minus 5x minus 36. If you think you got it, the idea, try to stop the video here and perform the operations. So that's, okay, so I'm just going to keep on continuing. That would be positive, negative. Okay, the reason why I am putting the larger number as the negative number, the absolute value of the number is the larger, because when I add them together, I want them to add up to negative 5. So 1 minus 36 is negative 35. 2 minus 18 is negative 16. 3 minus 12 is negative 9. And 4 minus 9 is negative 5. So outside there's the negative, and then I have x plus 4 for the positive 4 times x minus 9. You're going to have to make those decisions where you're going to have to decide which one is positive and which one is negative. For these, the instructions say to find the greatest common factor and then factor. So looking at 7n squared minus 21, there's a common factor of 7 that I can take out. If I were to divide 7, like this, in your head, you're doing this to factor. Sometimes people can do it without this extra step, and that's fine. If you need to do the extra step, you should do that as we start. Okay, the one on top, let's see, looking at B, we have 9x squared plus 9x minus 18. There's a common factor of 9. That will give me x squared plus x minus 2. And then I need to find the factors of negative 2, that's C, that add up to B, 1. The 1 comes from this value here. Technically, there's an invisible 1. Okay, the factors of negative 2 that add up to 1 are 2 and 1. And if you think about it, would I have to subtract 1 from 2 or subtract 2 from 1? You have to subtract 2 from 1 to get, sorry, you have to take 1 away from 2 to get this positive 1 that's right here. So we get x plus 2 times x minus 1 is my completely factored form. Okay, so looking at C, I'm going to start with the greatest common factor. 4x squared, 8x, and 12 all have factors of 4. That will leave me 1x squared plus 2x plus 3. Now I need to find the factors of 12, that's the C value, that add up to B. In this case, B is 2. Oh, I apologize. C is now 3. Okay, what are the factors of 3 that add up to 2? Factors of 3 that add up to 2. Okay, there are none, because the only factors of 3 are 3 and 1, and those do not add up to 2. So it's prime at this point. You can only factor out the 4. You're done. 18y squared, 19y, and negative 27 in example 3 have a common factor of 9. When I factor out 9 from 18, I get 2y squared. 9y divided by 9 is 1y. Negative 27 divided by 9 is negative 3. Okay. I'm going to use a different method. It's called factoring by grouping. So we're going to come back to D. Okay, so here we go. Now, let's say A does not equal 1 like in our last example. So here A is 2. In example A is 4. Okay, you should always look for the greatest common factor first. 4, 7, and 3 do not have a common factor other than 1. So we are ready to go on to the next step. It says find the factors of A times C. So here's A. A is 4. And here's C. C in this case is 3. So if I were to take A times C, I would have 3 times 4, which is 12. So we want to find the factors of A, C. It says equals to B, but it's a little bit different than that. So I want to find it that they are A plus, it says it right here, sorry. These are the factors of AC that add up to B. So B in this case is 7. Can you think of two numbers when I multiply them, I get 12? There's 1 and 12, 2 and 6, 3 and 4. Did any of those add up to 7? Yes, 3 and 4. So what we're going to do is we're going to rewrite 4x squared plus 7x into 4x squared plus 3x plus 4x. And then just bring down the 3 from here. So this 3 is from this part here. This 4 is here. And we're just rewriting 7x to be 3x plus 4x. Okay, the reason why we're doing this is so that we can factor by grouping. So you take the first two and look for the GCF just of the first two. 4x squared and 3x have a common factor of x. That leaves us 4x plus 3. Okay, in the blue, there are no common factors for 4x plus 1. So I'm just going to write a plus 1 on the outside of the parentheses, 4x plus 1, plus 3, sorry. 1 times 4x plus 3 is 4x plus 3. So I have technically factored correctly. I have another common factor between the first term and the last term. I know that this doesn't look like one term, but it is. That's one term, and that's another term. And they're being multiplied by that 1 and that x. So I can take out the 4x plus 3. And what remains is x plus 1. So that is my new factor, and now I have completed that factorization. So let's try it again over here. I'm going to take A times C. 2 times 6 is 12. And see what factors of 12 add up to negative 7. That's my B value. Okay, so I have -3 times -4 will give me -7. Sorry, -3 times -4 is +12, I apologize. -3 plus -4 will give me -7. So I'm going to rewrite my quadratic as -3x minus 4x. And usually about now, my students ask, does it matter what order? It does not. If you put the -4x first and the -3x second, you'll get the exact same answer. Try it. So for the very first term, I get out an x. So what's left over is a 2x minus 3. The second term, I have a common factor of 2 only. But because I want a positive 2x minus 3, I'm going to take out a -2. Because -2 times 2x is -4x. And -2 times -3 will give me a +6. And those are the values above. So like I said again, that first thing is one term. This that I'm underlining is another term. So there's a common factor of 2x minus 3. And then what's left over is an x minus 2. So I've completed my factorization. Last example, 3x squared minus 8x plus 4. I'm going to make my little ACB cross. 3 times 4 is 12. What are the factors of 12 that add to -8? That's the B value, -8. So A times C is 3 times 4, that's 12. What are the factors of 12 that add up to -8? Okay, so I know it's not 3 and 4 again because that's 7, but we also have -2 and -6 that would work. And it doesn't matter what order you place these two. I'm going to put -2x first, but it works just the same if you put -6x first. Okay, then you're going to factor the first two. Take out an x. What's left is a 3x minus 2. And the second set of terms, I'm going to take out a -2 and get a 3x minus 2. If I were to distribute, -2 times 3x is -6x. -2 times -2 is +4. I now have a common factor of 3x minus 2, so that is going to come out in front. Remember, this is being multiplied here and multiplied there. And what's left over is an x minus 2. Factoring a perfect square trinomial. Sometimes it's really hard to tell if something's a perfect square trinomial until you factor it out. But if you notice that this is a perfect square, like 25 is 5 times 5, and this is a perfect square, 2 times 2, this might be the case. So this says that if I take the square root of the first guy, 25x squared, I get 5x. And take the square root of 4, I get 2. I may be able to factor this as 5x and 5x, 2 and 2. Okay, if it indeed is a perfect square, it has to have the same symbol. So am I going to put a plus sign or a minus sign? -2 times -2 is +4, just like +2 times +2 is 4. But if I make this negative, when I distribute, that would become a -10x and a -10x. And I will get that -20x. Okay, you don't have to do that step. This is just verifying that that's true. Your answer is 5x minus 2 quantity squared. So I'm just going to take the square root of the first number and the last number. Here I get 8x, and here I get 1. So I'm going to have 8x and 1 again. In my double bubble parentheses, 8x1, 8x1. And because this sign is minus, it's minus, minus. Okay, I'm going to take the square root of the first number, take the square root of the second number. I get 2x and 7. Since they're both plus plus, or sorry, this is plus, I'm sorry. Then it's just going to be 2x plus 7 quantity squared. Okay, this is when you check to see if the first and the last numbers are squares. If you don't know your squares, you might make a short list of them. We kind of started doing that when we're looking at parabolas. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. I would like that you guys memorize or know at least what these squares look like, or be able to tell if it's a perfect square. So what we're going to do here is we're going to take the square root of each value. So here we have 4x, and this one is 9, and we're going to add and subtract the two values. So you have 4x minus 9 times 4x plus 9. These are your factors. We're going to take the square root of 25x squared and 36. We get 5x and 6. So you're going to add and subtract these two values. Okay, take the square root of 9. The square root of these two, this would be 3m squared. This is 1. We're going to add and subtract those two factors. And then because there's a plus sign here, it's prime. Oh, sorry. 36 and 9 do have a common factor of 9. 4x squared plus 3. But that's all we can do because of this plus sign. We're done. Okay, I didn't assign any like these, so I'm going to go ahead and skip them. But please work on this assignment as much as you can. Remember, you get 100% for completion and showing your work. Have a good one. I'll see you guys next week.